Hello, I'm Alistair Stevenson, reporting for v3.co.uk, and today I'm in Detica's offices to see how they spot threats.
Hello, I'm Richard Wilding from Detica. I'm going to talk you through the technology we use to identify attacks in our clients' networks. What I've got here is the front end that our analysts use, and what we're not showing you today is the back end system that's taken in data from the whole network, vast quantities of data, and has identified and prioritised events of interest that our analysts should look at as a priority. On the left-hand side, we've got what we call our breakdown for our attack model, and essentially we're looking for a couple of key areas. So we're looking at how an attack infiltrates a network, how an attacker moves around that network, and how an attacker then stages data for stealing data from that network. And the example I'm going to show you is about infiltration. There are lots of ways an attacker can infiltrate a network. This particular example, which is based on a real attack but anonymized, is looking at email infiltration. So just way of volumes, we've probably in the real world environment would have ingested maybe 500 million events a day, stored that for around about a year, and got a vast quantity of data to do our modeling on. What we've done here is, as I say, prioritise that down to the top 50 to 100 things that our analysts should be looking at. And in this particular infiltration example, there are 17 types of infiltration events that we're going to take a look at. So what I can do is I can go and pick up the event of interest and drag it down onto this canvas. And what the system's done for me is it's shown me some key elements of the event. So I've got the sender of the email, I've got the subject of the email, and I've also got something here showing me that when we looked at that email as it went past one of our sensors, we noticed that there was a link to a website inside the email. And we pulled that out as something that's very interesting. And the reason it's very interesting in this example is that we've also seen it further down in the attack model in what we call a drive-by alert. So this is a web URL which, when visited, results in a new executable being downloaded. What the analyst can use the tool for is to dig around and ask questions of the data to understand if this is a benign event or if indeed it's a malicious event. I'm going to start by looking at the alert. I can simply interact on the graph here, and I can right click and ask to see the full details of that alert. And in this instance there are 2 internal IP addresses that went to that website. I can see them here, and I can see that the drive-by resulted in an executable being downloaded. And a drive-by, what we mean by that is it's a URL that, when visited, results in a number of redirects that result in an executable being downloaded. Now, there could be valid reasons for that. It could be software updates. Typically, a vendor may redirect you so it can track who's downloading. So not every drive-by or redirection behavior is bad, but there's behaviors or indicators about this one that suggest it is potentially bad. To understand more, again, I can pick up those alerts or those details and I can throw them back down onto this canvas. And the system's automatically done some what we call enrichment for me there. So it's showing me that there are, as I say, 2 computers visiting it, or 2 IP addresses, and it's automatically saying at the time the IP address visited that website, it was in use and allocated to this system in the network. At the time that system went there, the system was in use by that user, and that user has that email address. And there's a similar pattern on the other strand as well. So here we see the second IP address, we see the system in use by that IP address, we see the user who was using that system, and we see the email address of that user. So that's the first avenue of investigation. I now want to go and look a bit more at the email itself. So again, I can investigate via this graph and this canvas, and I can go and pull back the email metadata. And here at the top, I can see the time it happened, I can see what IP addresses it came in on, I can see the recipient and all the different information you'd expect. It's much more useful for me as an analyst though to get that data and just put it onto the graph again. And when I did that, something very interesting just happened. I'll just lay it out again. You can see that it's 5 of those emails, there were 5 emails in total. 3 of those emails I don't have any outward connections on, but 2 I do. And the first one is up here, and actually it's joined up with the other loop, or it's made a loop with the other investigation I did a second ago on the alert. The same is true for the second one. So I can very quickly build a hypothesis that 2 recipients of that email clicked on that link and visited that website. I can find out more. I can go and delve into the actual systems themselves. So again, I can right click on the canvas here and I can pull back new processes. So this is showing me every new application started on those 2 systems in the last 24 hours. Now one of those systems has something new called setup.exe in the Windows temp directory. That's pretty standard. Doesn't mean it's safe, but it's pretty standard to be there. What's far more interesting though is this one, so fonts.exe in the recycler folder, and that's common to both of the systems that received the email, and it's also suspicious because the recycler bin is rendered in a special way, typically by Windows. So most people that view the recycle bin wouldn't see that there, so it suggests that someone's trying to hide their tracks. And to know for sure, what I can do is I can interact again through the graph, and I can go and pull back that file now and start doing some reverse engineering to say, is that really a font? Or is that more likely, in this case, a malicious piece of software? So just zooming back out and looking at that picture again, what we see here is probably half a dozen or so different data sources all in one place. Behind the scenes, to build that picture, there's probably another half a dozen or dozen or so data sources that the systems use to stitch that picture together. And really what we're seeing is the tool can be used by an analyst, a security analyst, to build a very rapid picture and understanding of events, much quicker than they can do with typical systems.
Brilliant. I'm Alistair Stevenson. Thanks for watching.